All right, so it looks like everyone's back. Today we're going to be talking about exponential functions, inverse functions, and derivatives of inverse functions, okay? And this might be a little bit of a shorter section for the reason that on Tuesday I was instructed to give the Tuesday section a little bit of time to finish their quiz, but I think you guys have finished your quizzes already, so I don't have to give you extra time, but I still want to keep the sections roughly aligned. Another thing is, a few people emailed me and said that it's easy to put an F in the chat if you understand, but it's hard for me to tell who doesn't understand with the Fs in the chat method. So okay, good, I'm glad you agree. So if you understand, I still like the Fs in the chat, but if you don't understand, you can also private message me and I'll try and explain. Oh, someone says, oh, you haven't finished taking the quiz. Didn't you have a 24-hour? I thought you had a 24-hour time window to do the quiz. Oh, it started today? What? Okay, well then we'll try and have a shorter section today as well. Oh, that's crazy. Okay, I didn't realize that. Okay, well in that case, I'll still try and keep it short. Thanks for letting me know. I'll try and keep the section as short as I can. And then if you need to leave or you want to leave early to work on this on the quiz, you can leave early and just watch the rest of the section on the recording if you want to. Okay, so let's get started then, because I'll try and give you a bit of time. Okay, so the first thing that we're going to talk about today is exponential functions. Yeah, okay, so then I won't do any more breakout rooms today. I'll just try and go quickly. So exponential functions and their derivatives. So last time we talked about what is an exponential function, and today we're going to talk about how you find its derivative. So the first thing that you need to know is that by definition, the derivative of e to the x is equal to e to the x. And I can't give you any justification for this fact because this is just definition right now. And we need this as a starting point to find the derivative of any exponential function. Okay, so then the question is, we know how to find the derivative of e to the x. How do we move from being able to derive e to the x to being able to derive something more general like a to the x, where a is any real number? So the way that we're going to do this is, well, we can rewrite a to the x as e to the log or natural log a to the x, okay? And then using the log rules that we talked about last time, we can rewrite this as e to the x ln a. And now let's just take a derivative. So d dx of e to the x ln a is equal to, okay, so we use the chain rule. The chain rule first, we have to take the derivative with respect to the outer function, which is e to the something. And so e to the something has a derivative e to the something. And then that something is x ln a, so we take the derivative of that and we get ln a. Okay, but then we can just simplify that and we get a to the x. Remember, this is just the conversion that we did earlier. And so this gives us a to the x ln a as the derivative. Okay, so F's in the chat if you're happy with this. And again, you can message me if you're not happy with this. Okay, great. So I think I see all F's and no unhappies right now. Good. So what else? Okay, so let's do a couple of examples. Let's try and find the derivative d dx of 2 to the x times x plus 3 to the x, and also d dx a to the b to the x. So the first one, the first problem, you're going to be able to just apply the formula that we used earlier. But the second question, you'll have to understand how we derived the formula in order to solve it. And remember, if you look in the notes that I sent, you'll see a hint if you're confused. Okay, so actually I lied. I am going to put you in breakout rooms for a couple minutes for this. All right, so go think about these for maybe 5 minutes. You can't access the overleaf? Is this a problem that more people are having than one? Oh, okay. Oh, okay. So you just have to compile it, okay? You just have to recompile it. Your access is restricted. Yeah, I can try sending it again. There shouldn't be any restricted access. Okay, so try this. If it doesn't work, if this one doesn't work, then the hint that I was going to give is just that you can rewrite a to the b to the x as e to the b to the x ln a. So maybe you already knew that though. Okay, so not that many f's. That's okay. We'll go over it. So let's go over the first one first. Okay, can I at least get f's in the chat if you solve the first one? Okay, good. I did something horribly wrong if you can't do the first one, possibly, or if many people can. Okay, great, great. So let's do it. First, let's just apply the product rule. So the product rule says that first we take the derivative with respect to the first term, and this is just going to give you 2 to the x ln 2, okay? This is just by the formula that we got earlier, and then we multiply by the other term, which is x plus 3 to the x. And then we add, so we keep the first term the same, and then we take the derivative with respect to the second term, and that just gives you this. Okay, everyone happy with this? You should be happy with this. Okay. Can I? Yeah, you can leave it like this. There's no point expanding it all out. You don't learn anything. Oh, I don't know if you can leave it like this on a quiz or something, but in section, just leave it like this. It's a waste of your time to do more. Okay, so here you can write, for the second one, you can write this. And this is using the same process that we used before in order to get the derivative of a general exponential function. So here you're just rewriting a to the b to the x as e to the b to the x ln a. And this just comes from, again, ln a to the b to the x. So e to the ln a to the b to the x is just equal to a to the b to the x. And it's also equal to e to the b to the x ln a. Yeah, so is there a question?
Yeah, just real quick on the previous one.
Yeah.
So like I noticed like I don't know, I hope like there's like the same rule for like that we apply to 2 to the x, that we apply to 3 to the x. So I just skipped all the work. Do you think that'd be acceptable on a quiz? If I showed all my work for 2 to the x, do I have to show all my work for 3 to the x?
Oh, you mean for finding the derivative of 2 to the x?
Yeah.
You probably don't have to show how to do that. I just think it's important to know. Because I think you learned in class that the derivative of 2 to the x is 2 to the x ln 2. And so then you don't have to rederive it every time. You can just use the formula that you know. But I think it's important to know, because if you didn't understand the process, then it'll probably be impossible for you to do the next problem. Okay?
Okay.
Yeah.
Thank you.
All right, yeah, because it's too much time to rederive it every time. Okay, so then, great, we know that we can rewrite it like this. And now let's take the derivative. So again, we're just using chain rule. So we get e to the x ln a for the first chain part of the chain, so just the entire function. And then for the inner function, we get d dx b to the x ln a. Okay, and now this thing's just a constant, and b to the x, we know how to find the derivative already. So we get e to the b to the x ln a times b to the x ln b. So that's the derivative of b to the x times ln a, and that gives you e to the b. Oh, okay, so then you can simplify this again, because you can move this up here. And then you get a to the b to the x, b to the x, ln b, or ln a, ln b, okay? And that's the answer. Is everyone happy with this? Is anyone unhappy with this? F's in the chat if you're happy with this. Where did ln a come from? The ln a was just a constant. So when we took the derivative of this part, we know that this part is just b to the x ln a. And so then its derivative is d dx times d dx of b to the x times ln a, because we just pulled the constant down, okay? Great. Okay, so let's keep going. Let's keep going. So now we're going to talk a little bit about inverse functions, all right? So first, how do we know if a function has an inverse? The best way to tell if a function has an inverse is using the horizontal line test. So the horizontal line test says if you have the graph of some function, like this, then it's not invertible if you can draw a horizontal line and the horizontal line passes through the function graph at multiple points. But if it's a function like this and we draw a horizontal line, so that these are just the axes. If we draw a horizontal line, it only passes through once, and so we know that this thing's invertible. And let me talk a little bit about why this is true, okay? So what does it mean for a function to have an inverse? This means that the function is one-to-one. So let me give an example. Let's say that you have some function f, okay? And let's say that you have two numbers, 1 and 2, that f acts on. Then f takes 1, say that f takes 1 to 1, and say that f takes 2 to 1 as well. Then what would the inverse function have to do? So recall the definition of an inverse is that if g is the inverse of f, then if we compose them, meaning we do g of f of x, then we have to get back x, okay? And so the reason the order is different here is because first we're going through f and then we're going through g. But so what would g have to do in order for g composed with f to give you back x? So this is your x. So then it means that g of f of 1 has to be 1, right? So that means that 1 gets sent to 1, and 1 has to get sent back to 1. So then 2 gets sent to 1. What does 2 have to be? So g of f of 2 also has to be 2. So 2 gets sent to 1 under f, and then under g, it means that 1 has to get sent to 2, okay? But this is a problem because it means that g is not a function because it sends 1 to both 1 and 2, and you learned probably a long time ago that a function takes one value to one value. It can't take one value to 5 values. Of course, it can take 2 values to the same one value, but it can't take one value to 2 values. This is the definition of a function. okay? And so what the horizontal line test is indicating is the horizontal line test says that, say that it's at height 3. For some value of y, which in this case is 3, these are all of the values of x that correspond to that y value. And so what this is saying is that all of these values of x give you the same y value 3 in this case. And so that means that if f, say, let's just make up some numbers. Say that this is -3 and this is -1 and this is 3. Then we'd have that f of -3 is equal to f of -1 is equal to f of 3, all of which are equal to 3. And that's very bad, okay, because it means that there's no inverse. Another way that you can find, so this is more of a way for you to determine whether you think a function has an inverse. In order to prove it rigorously, if proof is asked for, what you would have to do is actually find the inverse and then show that that inverse function satisfies the property of an inverse, okay? So let's look at a couple of examples of functions that do and don't have inverses, okay? So let's consider 3x squared plus 1. 3x squared plus 1 has a graph that looks like this, all right? And so let's apply the horizontal line test. We draw a horizontal line and we see that it hits the graph twice, okay? So now let's consider another example, x cubed plus 1, okay? So x cubed plus 1 has a y-intercept at 1, and its graph looks like this. And so it's pretty clear that no matter where you draw a line, you're only going to hit this function once, okay? My pen just stopped working. Maybe it's out of battery, let me check. No, it still has battery. Okay, so let's talk about finding the inverses of these functions, okay? So even though this function fails the horizontal line test globally, within this region where x is greater than 0, it clearly passes, okay? So let's talk about how to find the inverse. All you have to do is if you have a function y is equal to 3x squared plus 1, then what you do is you just flip x and y. And so flipping x and y gives you x is equal to 3y squared plus 1. And now you have to solve for y, okay? And solving for y gives you x minus 1 divided by 3, and then we take the square root. And normally the square root would give you a plus and minus, right? And that's bad, because if it gives you a plus and a minus, it gives you two values here and here, which isn't a function. But because we're saying that we're restricting to the domain where x is greater than 0, we discard the negative value and just leave the positive value. So that gives you this, okay? So this is the inverse of 3x squared plus 1, as long as I didn't make a mistake, on the positive axis, okay? Or where x is greater than 0. And in this case, we have a much easier job because we can just find the inverse globally, meaning on the whole plane. And so here we do the same replacement. We have y is equal to x cubed plus 1. So then we do x is equal to y cubed plus 1. Then x minus 1 is equal to y cubed. And then y cubed, because you don't have the plus or minus business, so you can just take a cubed root and you get cube root x minus 1, okay? And you can check in the privacy of your own home that these actually give you valid inverse functions. All right, so let's discuss how to find the derivative of the inverse functions. And we're almost done, so you'll have some time for your quizzes. So, all right, if you have a function f, how do you find d dx of f inverse of x? That's the big question. And so probably in high school, you memorized some formula to find the derivative if you already took calculus. And probably you also forgot that formula almost immediately after learning it. And so let me tell you how to derive this, because if you're on a test or something and you can't remember, it's actually very easy to rederive what the derivative of an inverse function is. So the first and key insight is that f of f inverse of x is equal to x, okay? It's very simple, but it's key to finding what the derivative of the inverse is. And so now let's just take a derivative of this thing on both sides. So d dx of f inverse of x equals d dx of x. And so that gives you 1 is equal to, okay, derivative of the outer function is d dx f composed with f inverse of x. And then the derivative of the inner function is just d dx of f inverse of x. And I had to write it behind because I ran out of room. And so now what can we do? We can just divide. We can divide this out. Then we get d dx f inverse of x is equal to 1 over d dx f of f inverse of x, okay? And so this is the formula that you probably memorized in high school. All right, is everyone happy with this? F's in the chat. All right, great. That's pretty good. So I think I'm going to stop while I'm ahead and leave you some time to work on your quiz, because probably no one has class until 11. And so then you have a cool 25 minutes to do your quiz if you want to. All right, great. Thanks for coming to section. And I should post office hours and start holding some office hours next week. Sorry, I've been a little bit slow about that. And again, if you want to find the notes or rewatch part of the section, you can just go onto my website and they're all posted there. All right, so thanks.